Introduction to Oracle Database. This chapter provides an overview. We'll see topics like about relational databases, schema objects, data access, transaction management, Oracle Database architecture, Oracle Database documentation roadmap. Every organization has information that it must store and manage to meet its requirements. For example, a corporation must collect and maintain human resource records for its employees. Made that a bit bigger there. This information must be available to those who need it. So an information system is a formal system for storing and processing information. An information system could be a set of cardboard boxes containing manila folders along with the rules for how to store and retrieve the folders. However, most companies today use a database to automate their information systems. A database is an organized collection of information treated as a unit, and the purpose of a database is to collect, store, and retrieve related information for use by database applications. A database management system is software that controls the storage, organization, and retrieval of data. So I guess if we throw in the word management there, now we're implying a retrieval, maybe a moving around by however the information system person in control, person in charge decides. Well, typically a DBS has the following elements. So a database management system has kernel code. This code manages memory and storage for the DBMS. So I simplified that really by asking the question, what does the kernel code of a DBMS seek to achieve? It seeks to manage memory. Now, repository of metadata, this repository is usually called a data dictionary. I have a book called Data Dictionaries. All right, so now we'll understand the semantics a bit better. There's a query language. This language enables applications to access data. So a database application is a software program that interacts with a database to access and manipulate data. The first generation of database management systems include the following types. So you have hierarchical and a network. Hierarchical has these parent records with one or more child records, but a network database can have a many-to-many rather than one-to-one relationship. I mean, it can be similar to the hierarchical thing, the parent-child thing. Well, the preceding database management systems stored data in rigid, predetermined relationships because no data definition language existed. Changing the structure of the data was difficult. Also, these systems lacked a simple query language, which hindered application development. So the relational model, in his seminal 1970 paper, A Relational Model of Data for Large Shared Data Banks, E.F. Codd defined a relational model based on mathematical set theory. Today, the most widely accepted database model is the relational model. A relational database is a database that conforms to the relational model, and the relational model has the following major aspects. So we have structures. These are well-defined objects. They store or access the data of a database. Then we have operations. Clearly defined actions enable applications to manipulate the data and structures of a database. Okay, so a structure is just about putting in or taking out. It's making me think of just reading and writing. That's what a structure does. An operation can manipulate. That's just so simple, I'm not even going to create a question on it. We have integrity rules. These govern operations on the data and structure of a database. Now, a relational database stores data in a set of simple relations. A relation is a set of tuples. A tuple is an unordered set of attribute values. A table is a two-dimensional representation of a relation in the form of rows and columns. They're calling rows tuples and columns attributes. So let's get our semantics right here. Each row in a table has the same set of columns, and a relational database is a database that stores data in relations. So relations are tables. For example, a relational database could store information about company employees in an employee table and a department table and a salary table. All right, so this is all very straightforward so far. When we see the term RDBMS, an RDBMS moves data into a database, it stores it, and it retrieves it. The thing doing the manipulation or the operations is the applications. Now we have logical operations on it, and then physical operations. In this case, the RDBMS determines how things should be done and carries out the operation. For example, after an application queries a table, the database may use an index to find the requested rows, read the data into memory, and perform many other steps before returning a result to the user. The RDBMS stores and retrieves data so that physical operations are transparent to database applications. Oracle Database is an RDBMS that implements object-oriented features such as user-defined types, inheritance, and polymorphism. This is called an Object Relational Database Management System, or ORDB. I have no idea how we can try to pronounce the acronym into a wittier way of saying it. The O is for object, not Oracle. So this relational model has been extended to become an object relational model, making it possible to store complex business models in a relational database. So they're going to give a brief history here. I am going to skip it, not needing to read that. If we're going to talk about schema objects, one characteristic is the independence of physical data storage from logical data structures. In Oracle Database, a schema is a collection of logical data structures or schema objects. A database user owns a database schema, which has the same name as the username. So a schema is a collection of data structures or objects. A database owner or database user owns a database schema, which is the same name as the username. Schema objects are user-created structures that directly refer to the data in the database, and the database supports many types of schema objects, the most important of which are tables and indexes. So this helps me wrap my mind around things a bit better. A schema object, first of all, it's a user-created structure, and so an object could be like a table or an index. When I think of index, I'm kind of thinking of like dictionaries or pairs. All right, so that's what a schema object is. So if I'm thinking of a schema, I'm thinking of maybe the overall way I organize these tables. And this is good to know. A schema object is just one type of database object. We're going to see some other objects such as profiles and roles. There we go. So we took note of those examples. We can look more into an overview of tables or data integrity, but let's keep going. Indexes. An index is an optional data structure that you can create on one or more columns of a table. Indexes can increase the performance of data retrieval. When processing a request, the database can use available indexes to locate the requested rows efficiently. Kind of sounds like an index is like a key, maybe a primary key. Indexes are useful when applications often query a specific row or range of rows. Indexes are logically and physically independent of the data, thus you can drop and create indexes with no effect on the tables or other indexes. All applications continue to function after you drop an index. And there's more about indexes we can read. Now, SQL is a set-based declarative language that provides an interface to an RDBMS such as Oracle Database. Procedural languages such as C describe how things should be done. SQL is non-procedural and describes what should be done. SQL is the ANSI standard language for relational databases. All operations on the data in an Oracle database are performed using SQL statements. So for example, you use SQL to create tables and query and modify data in tables. So many ands there. So to create tables, to search those tables, and to modify the data in those tables. Pretty easy, 3 things. So a SQL statement can be thought of as very simple but powerful program or instruction, whatever way you want to describe it. Users specify the result that they want. So for example, the name of employees, not how to derive it. What does derive it mean in this context? Like not how to create it or not what to do with it. Anyways, a SQL statement is a string of SQL text such as the following. Now forgive me if you hear me say SQL. SQL is the right way I'm trying to say it, but sometimes I fall back into bad habits. All right, here's our example. So first select the first name and the last name from a table called employees. SQL statements enable you to perform the following tasks: to query to insert, update, and delete rows in the table, to create, replace, and alter or drop objects, control access to the database and its objects, or guarantee database consistency and integrity. SQL unifies the preceding tasks in one consistent language. Oracle SQL is an implementation of the ANSI standard. Oracle SQL supports numerous features that extend beyond the standard SQL. So let's look at PL/SQL and Java. So this PL/SQL is a procedural extension to Oracle SQL. It is integrated with Oracle database. It enables you to use all of the Oracle database SQL statements, functions, and data types, and you could use this to control the flow of an SQL program. All right, so I wrote that in question form. What can you use PL/SQL for? All right, so first answer, to control the flow of the program, to use variables, and even write error handling procedures. A primary benefit of PL/SQL is the ability to store application logic in the database itself. A PL/SQL procedure or function is a schema object that consists of a set of SQL statements and other constructs grouped together, stored in the database, and run as a unit to solve a specific problem or to perform a set of related tasks. The principal benefit of server-side programming is that built-in functionality can be deployed anywhere. Okay, so we'll wrap the video up with this here. And I'm even going to be lazy and just type PL/SQL with no slash. So what's a primary benefit? And I think this is pretty cool. You can store application logic inside of the database there. And another good thing I thought we should take note of is, like, what are these procedures? They themselves are schema objects, seeing how we just read a bunch about what a schema is and a schema object. So we know of an object being a table. Well, this procedure is now an object. It's an object that just so happens to consist of a set of SQL statements. So with that set sitting in the database, it can be ran as a unit to solve a specific problem. So to finish this video, Oracle Database can also store program units written in Java, and a Java stored procedure is a Java method published to SQL and stored in the database for general use. You can call existing PL/SQL programs from Java and Java programs from PL/SQL. So that's the end of this video. I'm going to go ahead and jump over to Stack Overflow and see what I can read about PL/SQL.